Hi, my name is David Walker, and I'm going to talk to you about one of my projects for my master's under the direction of Dr. Dan Reynolds at Mississippi State University, titled Comparing Non-STS, STS, and Bolt Soybean Susceptibility to Grasp and Regiment Herbicides. In the state of Mississippi, soybeans and rice are the first and fourth most valuable crops, respectively. With them being this valuable, there come many instances where these crops are planted in close proximity to one another. With this close proximity comes an increased potential for off-target movement of applied herbicides between these crops. It is also important to note that many herbicides applied to these crops are not labeled for use in other crops. One of the most common herbicide chemistries used in rice production in Mississippi are ALS or acetolactate synthase inhibitors. These herbicides control barnyard grass, which is a critical weed in rice production. Grasp or pinoxylum and Regiment or bispyrobacter are two effective options for controlling this weed species. However, it is important to note that these herbicides are not labeled in soybeans and are highly injurious to them. When discussing rice and soybeans in the state of Mississippi, it's important to observe the planting window for these two crops. While these crops have a relatively similar beginning or start date of the planting window, the rice crop is in the ground almost an entire month before the soybean crop is. Due to this, there are many instances where there are soybean plants that are at a relatively younger or lower growth stage and therefore more susceptible to plant injury. In 2015, DuPont Pioneer released the Bolt soybean system as a non-transgenic technology to tolerate lead-off and basis blend or rimsulfuron and thiophensulfuron methyl burn-down applications as an immediate plant-back option. These soybeans were a further development of STS or sulfonylurea tolerant soybeans and were plants that exhibited higher tolerance than STS plants. This soybean system was a limited launch with availability only in select maturity groups and varieties. However, Pioneer is expected to release more maturity groups and varieties with the Bolt technology in it in the upcoming years. Now moving to the research rationale. Grasp and Regiment are herbicides of the same MOA or mode of action as lead-off and basis blend. It has been suggested that this Bolt technology might allow increased tolerance to Grasp and Regiment. If tolerant, Bolt soybeans could be planted in areas of close proximity to rice fields. Then these soybeans could be used as a drift mitigation tool to alleviate off-target deposition of rice herbicide applications to these beans. The overall objective for this study was to evaluate available ALS technologies for differential tolerance to Grasp and Regiment. This study was conducted in two locations, at the R.R. Full Plant Science Research Center in Starkville, Mississippi, and the Black Belt Branch Experiment Station in Brooksville, Mississippi. Moving to the materials and methods, the study was a randomized complete block design with 4 replications, and each plot was 12.8 feet wide or 4 38-inch rows by 40 feet long. The treatments were arranged in a factorial arrangement with 3 factors. The first, factor A, being the ALS technology level, which was non-STS, STS, or Bolt. The second, factor B, was the maturity group of the soybean, with there being a late group 4 or an early group 5. The final factor, C, was the herbicide treatment, with the first being a single application of Grasp at a rate of 0.7 fluid ounces per acre, the second being a single application of Regiment at a rate of 0.1 ounces per acre, and the third being an untreated check to compare each herbicide to. Continuing with the materials and methods, it's important to note that all Grasp treatments will include methylated seed oil premium blend surfactant at a rate of 1 quart per acre, while all Regiment treatments will include Dynapac adjuvant at a concentration of 1% volume per volume. All treatments will be applied using a CO2 operated backpack sprayer calibrated to deliver 15 gallons per acre at a pressure of 40 pounds per square inch using TJET TTI 110015 spray tips. Also, all applications will be made at the V3 growth stage, and the entire experimental area will be kept weed-free and pest-free throughout the growing season. Concerning data collection, visual estimates of the percentage of plant injury were taken at 7, 14, 21, and 28 days after treatment. Also, plant heights and node counts were recorded at 14 days and 28 days after treatment, and then also 1 week prior to harvest. Also, yield data was collected at the end of the growing season and expressed in bushels per acre from the center 2 rows. And then all data was subject to analysis of variance using SAS 9.4. The program we used was ProcGlimix. Moving to the results, the first graph is the percent plant injury taken at 28 days after treatment, averaged over herbicide treatment, and grouped by our ALS technology level. So to set up this graph, on the y-axis we have the percent plant injury, or the parameter of interest, and on the x-axis we have the 3 groupings of the ALS technologies along with the herbicide treatment for each. So right away we noticed that bolt soybeans treated with Graspin Regiment exhibited no plant injury, while non-STS beans treated with Graspin Regiment exhibited the most plant injury. Moving to our plot pictures, we start with non-STS beans treated with Grasp. As you can see, our grasp-treated beans have common ALS inhibitor symptomology with a reduction in canopy size, chlorosis of the foliage, and a shortening or stacking of the internodes. Moving from non-STS to STS treated beans, we notice that the overall injury is slightly decreased from the previous. Also, we see, however, that there's still a presence of chlorosis and node stacking and canopy reduction. Finally, moving to the bolt treated beans, we notice that they are practically identical to the untreated check, except for maybe a slight reduction in canopy size. Moving from grasp treated beans to regiment treated beans, we notice that regiment had an overall increase on plant injury, with even more stacking of the nodes and even shorter canopy size than the grass treated beans. Moving to the STS treated beans, we again notice the stair-step effect where the STS treated beans had significantly less injury than non-STS. And again with the bolt regiment treated beans, we notice that they are practically identical to the untreated check, with just a slight tinge of chlorosis and a slightly shorter canopy size. Next, we have our plant heights taken at 28 days after treatment, averaged over herbicide treatment, and grouped by our ALS technology level. When observing this graph, it's important to note that bolt soybeans treated with Graspin Regiment were the only soybeans that did not differ between their untreated check, while non-STS treated beans again had the greatest reduction or difference in plant heights compared to its untreated check. The next graph is our plant heights taken at 98 days after treatment, averaged over soybean maturity group, and grouped by our ALS technology level. While we would expect to see the early maturing beans, such as the group 4.9s, having a shorter plant height than our late maturing beans or the 5.1s, it's important to note that with bolt soybeans there was no difference among plant heights between these two maturity groups. Finally, we have our average percent normalized yield of the untreated check grouped by ALS technology level. Right away, when we look at this graph, we notice that bolt soybeans and STS soybeans did not have a difference in normalized yield. However, they were greater than non-STS treated soybeans. Moving to our conclusions, first we can note that bolt soybean varieties showed significantly less injury than other varieties, therefore making them more tolerant to ALS herbicides. Expanding on that, bolt soybean plant heights were also not affected by these herbicides. Furthermore, bolt soybean plant heights did not differ among maturity groups, therefore showing their ability to outgrow the potential injury. Finally, the yield of both soybean varieties was not statistically better than STS varieties, but was greater than non-STS varieties. This study will be repeated during the 2017 growing season to confirm this data at the same locations. Also, there are additional studies currently going on involving bolt soybeans. One evaluating bolt tolerance to various concentrations of grasp and regiment, and the other evaluating the effect of the crop growth stage on the susceptibility to the off-target deposition of grasp and regiment herbicides. I'd like to acknowledge and thank the Mississippi Soybean Promotion Board for funding this research project and making it possible, and then I would also like to thank Dr. Dan Reynolds and Dr. Jason Bunn for their direction and guidance, and all the members of our research crew for helping me make this project happen. Thank you for your time.